In this lesson, we shall focus on the grade 10 mathematics paper 1, a provincial examination that was written in June 2022 in the Gauteng province. It was written out of 50 marks in 1 hour. Right, and we go through the paper together right now as follows. Right, here is question 1 and 1.1. Given a equals 1 divided by the square root of 3 plus x. Now, x is an element of the set with the elements 0, 1, 2, and 3. For which value of values of x will the expression a be rational for 1 mark? So we must choose the values of x for which a is going to be rational. So how do we choose this? How do we choose? Okay, first things first, we do it as follows. So we then say, for example, if x, so we experiment. If x is equal to 0, right? If x is equal to 0, a equals 1 divided by the square root, like so, right? Then we have 3 plus 0. And this is 1 divided by the square root of 3. And as a matter of fact, this expression here is irrational. It is irrational. Next, because x can be 0, 1, 2, or 3. So the next one you're going to put, so this skill you need even at grade 11. So x can be 1 next. Right, so x can be exactly 1. So if x is 1, we put a equals 1 over the square root. Right, so obviously 1 over the square root of 3 plus x. So it is 3 plus. What is x? X can be 1. 1 over the square root of 4. What is square root of 4? Is 1/2. Right, so what then do we have here? Right, so, and the number 1 out of 2 is rational. It is a rational number. What is a rational number in mathematics? A rational number is a number that is formed by an integer divided by an integer. So rational numbers are the kinds of numbers denoted by the set Q. And the set Q contains numbers of the form a divided by b, such that AB is an element of Z, and Z is a set of integers. What is Z? The integers. Okay, so Z contains what we call integers. What are integers? Integers are counting numbers with 0 and the negatives. Right, so would have this. So these are called integers. Okay, so the integers are like this. We continue quickly without wasting time. Next point. If x equals 2, a equals 1 over the square root. 3 plus. What is x? X equals 2 this time around, but yeah, we're testing all of them. And a would be 1 divided by the square root. Okay, but the formula is this one. So x changes amongst these values. So we try next 2. So it's going to be 3 plus 2, which is 1 divided by the square root of 5. In the square root of 5, you do your calculator, it's going to be 1 point something. And this one is the square root of 5 is irrational. So 1 divided by that is irrational. Irrational. Then if x equals, the last one is 3 because we've gone through 0, 1, 2, and the last one in the set is x equals 3. Okay, we experiment with this one here. So now x is 1 over 3 plus the square root of x. X is 3 here. What is 3 plus 3? 6. And the square root of 6 itself, you go to your calculator, it is irrational. Well done. I'm happy that Mpo can realize that it is irrational. Right now, because of this, now they want the one that is rational. They are saying for which value of values of x will the expression a be rational? So rational is only one. Where this rational, it is rational, this because it is an integer over an integer. One is in the set of the integers. Okay, now let's look at the set of integers. Here is one. And then 2 is out of the set of integers. And now we take 1 divided by 2, and this forms an integer. If we divide two integers like 1 divided by 2, or 2 divided by 3, or -3 divided by -2, all these are numbers that are called rational numbers. Okay, so yeah, so 1/2 is a rational number. Why is it rational? It is an integer of an integer, so 1 out of 2. But the rest, because the square root of 6 here, the square root of 6 here is not in the set of integers. There are no square roots here in the integers. Okay, there are no square roots in the set of integers. But now the only square root you can put in the integers is the square root of 9. Or you can put the square root of 4. You can claim this one can be put inside the set of integers because the square root of 4 is 2. And the number 2 is what? What is the number 2? The number 2 is here. So yeah, the square root of 4 is 2, and therefore it's an integer. The square root of 9, what is it? 3, and 3 is an integer. Yes, the square root of 9 is an integer because it is equal to 3. Next point, we move forward. Right, in our next treatment of questions, we're looking at 1.2, and we're going to be looking at 1.2.1. Factorize the following fully. Okay, what do we do first here, Mpo? What do you think? What do you think?
Over the highest common factor or the lowest common factor.
Well done. We work at the highest common factor. And what is the highest common factor here?
X squared.
Okay, never mind. It is because now this one is divisible by 2. 32 is divisible by 2. What is 32 divided by 2? It's a 16. So it means, therefore, we can factor out 2. And if we factor out 2, how do we factor out 2? So if you factor out 2, then you cross this out because you divide 2 by 2. So you have x squared. If you factor out 2, you divide 32 by 2. What is 32 divided by 2? Okay, it's a 16. Never mind. I tease you with these things. Okay, what do we do here, Paul, next? Because we need to factorize fully. Like full, in full. What do we do?
Auto bullet bracket 2.
Open at the bracket, say 2. Well done. Because of the x squared. The x squared means bracket say 2, right? Next, what do we do?
And then ungola x both sides.
X both sides. Excellent stuff. Well done. And then what do we do?
And then ungola plus or minus.
Ungola plus minus. Okay.
And then ungola
Yeah.
16. Factors of 16.
Factors of 16. Well done. Yes, the factors of 16. The factors of 16, which when we add, give 0 because there's no middle term here. There's no x term. So there must be equal factors of 16. And what are those?
Okay, 8 times 2, you for 16.
8 times 2, that's good. 8 times 2, we for 16. But again, you see 8 times 2, when we add them up,
For 10.
for 10, but yeah, and there's no 10 here. Right? And obviously, this one becomes something like called the difference of two squares. If there's like a squared minus b squared. A squared minus b squared, the bracket say 2 like this for the difference of two squares. Then ringwala plus minus. Then obviously now bracket say 2 because it's a squared Kenya a. Then b squared, we put b here and put b there. And so that's the formula for difference of two squares. And do the same here, because this 16 can be written as a perfect square, and it is the same as what? 4 squared. 4 squared. And therefore, because it's the same as 4 squared, we do this. So that's like the 4 is like our B, and then we put plus B minus B. So we're gonna put plus 4 minus 4. Okay, so make sure you get these ones right. Okay, let's factorize this one. X squared minus 9. What are the factors, Simpo? X squared minus 4. What are the factors? Yeah, let's start with minus 9. Mm-hmm.
Ya 9.
Yes.
It's over king 3 times 3 ke 9.
3 times 3 is 9. So it's gonna be 3, 3. So we can write it as like x squared. The 9 can write it as like 3 squared. Right. So that obviously, I mean, immediately put bracket say 2, the Kenya x, then plus minus. Okay. Let's look at x squared minus 4. What do you think?
2 2.
2. Well done. 2. Then obviously because of the x squared and Kenya x, then plus minus. Okay, good. Let's move to the next question. So now this one to factorize fully, this is the answer. And at this point, we'll have factorized fully and we are done. Okay. Okay, next question. 1.2.2, Paul. All right, so in 1.2.2, we need to factorize this one. Factorize the following fully. The word fully means we must leave like nothing not factorized. Yeah?
Okay, no. Open bracket 2 minus 3b also simplify before factorize.
Before factorize, all right? Yeah, that's awesome news. Just simplify Billy. Well done. This is awesome. So this is actually 6a squared minus b, then real distributor. This is called distribution. So if we simplify Billy, then it becomes a times 2, which is 2a. And then we have a times minus b, which is minus 3ab. Then what do we do next?
And then we correct the
yeah, the like terms and whatnot, yeah. Right? Okay, we collect the like terms. Then if we collect the like terms, what do we get here? Or what is next? What is the next thing here?
6a squared minus 3ab.
Okay, 6a squared
plus 2a.
Okay, yeah, we can 6a squared, right? Yeah, 6a squared
minus 3ab.
Yeah, then there's minus 3ab. Okay, now if you have the minus 3ab, all right, yeah, then what do we do next? What do we do next?
Minus b plus 2a.
Okay, yeah. So yeah, one thing is you can put the 2a like this because these ones are like have a and a in them. Then we have the others that have like b. So we put what else do we put here, for example? So if you minus 3ab, so we can put the terms that have like a like completely, and we put the a's together and we put the b's together, like the 6a squared and the 2a, and then we have the minus 3ab with the minus b put together. Do you see that?
Yeah.
Okay. Yeah, these are like terms. Yeah. Hello, my dear. Okay. Yeah. Yeah. That's fine. I'll sort you out. Yeah. After my class, my dear. Yeah, I'll make it clear after my class. Yeah, because I'm just having a class now. All right. Okay. Thank you, my dear. Okay. Right. Okay. Thanks. Yeah. So, you see that important. So, yeah, we have the a terms here, the 6a squared and the 2a, the 6a squared and the 2a, and then the minus 3ab and the minus b. So that in the end, then you'd have 2a like this. Then you'd have 3a and 1. Okay, because if you factor out 2a, then the place of this one, you're left with 1. Okay, if you factor out 2a, you divide 6 by 2, you get a 3. And then out of a squared, you take out 1a, you're left with 3a. And then here you take out b, in which case you're left with 3a and 1. You get the point. And then,
Yeah.
okay, yeah. And then now you take out the common factor 3a plus 1. Okay. So okay. So now we've factorized these. Any question, Paul? What did we do first? What did we do first? We grouped the A terms and the B terms. Like this one is a B and that one is a B. And then we grouped this one with A and A. And then it was a very huge breakthrough because we're able to realize, therefore, that this one here is going to be, you see, these two are A terms and these two are B terms. And these A terms, then we take out 2A, and then we have 3A plus 1. And we have here minus B, and we have 3A plus 1. Okay, and then now there was 3A plus 1, 3A plus 1, and this was like the highest common factor, the HCF. Okay, it was the highest common factor, 3A plus 1, 3A plus 1. Then we took it out. When we factor that out, we cross it out. Whatever you factor out, you cross out. And if you cross this out, you're left with 2A and minus B. Okay, think about this, Simple. Please think about this. Next point. Okay, also part of the exam is going to be like this. So you must be able to simplify the following completely. Let's do some simplification. Like in the event that like we have x minus 1 into open bracket, x squared plus x plus 1 close bracket. What do we do here? We need to simplify, but how do we simplify this, Simple?
Auto multiplier or x times x squared.
X times x squared. And what do we get?
X cubed. And then x times x is over x squared.
X squared. Brilliant stuff. And then x times?
X times 1 over x.
Then next, what do we do?
1 times x squared. Negative
Minus
1.
Yeah, negative 1 times x squared giving us minus x squared. And this times this?
Yeah. It's over negative x.
And this times that?
Negative 1.
Right. So next we have x squared minus that, x minus x. And what is the result? It's x squared minus x cubed minus 1. Yeah, what do you think?
Yeah, it is.
Easy, right? Easy. Okay, yeah, number 3. So yeah, we're gonna be left with, we're just left here with x cubed and then with minus 1. And then we're done. And then
okay, so how multiplier?
Yes.
The coefficient or what the adder?
Yes. If you multiply the coefficient that the adder, yes. When I multiply, don't multiply no matter re-adder the powers. Re-adder the powers. Because, well, in the following sense, if you're multiplying x times x squared, this x has power 1. So that x becomes like 1 plus 2, and the thing becomes 3 here. Okay, it becomes 3. Now, we added the powers, 1 and 2, and then we got 3. You get the point?
Yeah.
Yeah, we're adding the powers, and then we get what? We get 3. We added the powers, and then we get 3. Okay, next point. Okay, next, let's look at 1.3.2. Okay, part of the kind of stuff you expect to meet in the exam. This guy, this one here. What do we do with this? This one is long. Okay, but now the secret to doing this one is dealing with the denominator. The secret to doing this one is dealing with the denominator. And then now, after having dealt with the denominator, we do the following stuff. So yeah, what do we do here?
Ay,
Yeah.
it's difficult thing, yeah.
Yeah, it's difficult a little bit, right? Difficult, Nyana, right? Yes. What do you think we do? First things first, you always factorize the denominator of each of these. Always factorize the denominator of each of the denominators. So you have x plus 7 all divided by x minus 3, x plus 2. Minus 3 divided by x minus 3 plus 2 divided by 2, open bracket, x plus 2. Okay, so, okay, we factorize each of these denominators. Then the next thing is we write down the lowest common denominator called the LCD. Right, so we write down the lowest common denominator. What is the lowest common denominator here out of all these? Right, so writing down that one, we do what? What do you think we do next? What do you think? What do you think we do? Okay, so here there's x. This one is x minus 3, x plus 2. This one is x minus 3. This one is x plus 2. But we need to put 2 here. We need to put 2 there. Okay, but also we can note that this 2 cancels out here. Okay, because that 2 cancels out, we can just write down one more step, because you can see the 2 cancels out, and we can cross that out, and then have x plus 7 divided by x minus 3, x plus 2, minus 3 divided by x minus 3, plus 1 divided by x plus 2. And then you put a division like this. Okay, then now we've cancelled the 2. It was a common factor in the numerator and denominator. We then have x minus 3. So clearly the LCD at this point is a combination of this x minus 3, x plus 2. X minus 3, x plus 2. So you divide this one by this. Divide this one by this. You get a 1. 1 times x plus 7, which is x plus 7. This one divided by x minus 3. What is this divided by x minus 3? So if you divide this by x minus 3 is going to cancel, and you're left with x plus 2, and then x plus 2 times minus 3, with minus 3 times x plus 2. Like so. Okay, plus. We divide this whole thing by x plus 2, and we get x minus 3 by 1. We have x minus 3. Okay, good friends. Okay, now we have x plus 7. Okay, then we distribute here. Like that. Minus 3 times x is minus 3x. Minus 6 plus x minus 3. All divided by x minus 3x plus 2. What is x minus 3x? Minus 2x. Minus 2x plus x is actually minus x. Right, we have 7 minus 6, it's a 1. 1 minus 3, it's a minus 2. All divided by x minus 3, x plus 2. Like so. Upon careful examination, we have x. We factor out negative from the numerator, giving us x minus 2, and then the denominator, we have x minus 3, x plus 2. Okay, now these questions you need to like do them on your own when you watch the video again, okay? Because you need to watch the video. I'm going to send you the video, then you need to play back, and then you can try these on your own. Then if you cancel x plus 2, x plus 2, then you're left with minus 1 over x minus 3. And this is the answer. And this is the answer. It's minus 1 over x minus 3. Okay. Any question? Okay, this is how this question would be done. And this is the answer. And the question was where to simplify, and we have simplified, and there's nothing we can do to simplify this at this point. This is like the simplest we can get. The most simplified answer. The most simplified answer. Next point. Next question. 1.3.3. This one. What do you do with this one, Paul? This guy. Mm-hmm.
2 to the power of x times 2 to the power of 1
Yeah.
times 3.
Yes.
Times 3 to the power of 2.
Okay, please say again. Come again.
To the power of x.
What do you write? 2 to the power. Or 2 to the power of x. Okay, good. Doesn't matter. Okay. So, we write 2, right? 2 to the power of what? Please come again. I need to be sure I do well.
To the power of x.
2 to the power of x.
Times 2 to the power of 1.
Times 2 to the power of 1. Okay. Yeah.
Times 3 to the power of 2x.
3 to the power of 2x. Okay. Yeah.
All over.
All over.
3 to the power of 2. 3 to the power of 2x.
Okay. 3 to the power of 2x.
Times 3 to the power of -1.
Times 3 to the power of -1. Okay, this is all okay. But I want to bring to light something interesting here. Every time, this is the trick for you. Every time you walk into the exam, this is the first step you need to write when you see these questions. Always split. Always split like this. 4 to the power x, like this, 4 to the power x plus 1, 4 to the power 1. 9 to the power x is alone. The denominator, 6 to the power 2x, 6 to the power -1. Always do this. Always do this. You always split the powers that are like added together, but you write the same base. Like here, 4 to the power x, 4 to the power 1. 6 to the power 2x is the power -1. Okay? This is what you do first. Okay? Next what you do. Then now you can come to your step here. You can come to a step where you, after splitting everything, that's added like this, x plus 1, you split, you separate like that. There's 2x minus 1, you separate like that. Okay, after this, then you can come and do the powers. Okay, because the 4 is 2 to the 2, but there's x. Then 4 here is also 2 to the 2. 9, excellent stuff, is 3 to the 2x. I agree with you. The next thing is now you come to the 6 to the power 2x. 6 is tricky because 6 is not a perfect square, but you can write the number 6 as 3 times 2 to the power 2x times this. Right, so what do you do? What do you do?
Highest common factor.
Highest common factor, yes. Okay, good. Yeah, I agree with you. But this is the advice. This is the advice you can give to break this down with ease. This is the advice. Right. Okay. Okay, so this is 3 to the power 2x. Okay, yeah. So here you write 3 to the power 2x, then you have division. Okay, then if there are numbers that are not perfect squares, like 6 is not a perfect square, but 6 can be as a factors 3 and 2. But 3 and 2 are good factors because you can say also 6 has the factors 6 and 1, but now 6 and 1 are not good because there's the, you're going to be moving in circles. The 6 is not going to help, but the 2 and the 3 are popular here. Okay, so which means you're using the law of exponents. A times b to the nth power is a to the power n, b to the power n. which is z to the power 2x, 2 to the power 2x. And then okay, this is what you have. Aha. So what do you do now? This one cancels this one because we're multiplying, because there's multiplication. If there's multiplication, you can cancel. Then if you cancel, then at the top, you're left with 2 to the second power. At the bottom, you're left with 6 to the minus 1. And then it's 4 divided by 1 out of 6, which is 4 divided by 1 out of 6. 4 multiplied by 6 over 1. And then is 4 times 6 divided by 1 is 6. What is 4 by 6? 24. And so the answer is exactly what? 24. So any question, Paul? Any question, Paul?
Over the step from more canceling thing.
Yeah, I'm canceling thing. Okay, yeah, because now here line canceling thing. Now there are things that there's 2 to the power 2x here, and there's also 2 to the power 2x. And there's 3 to the power 2x, and there's also 3 to the power 2x. So 3 to the power 2x cancels 3 to the power 2x. 2 to the power 2x cancels 2 to the power 2x, leaving us with 2 to the power 2 and 6 to the power minus 1. Those are the only things that did not cancel. The 2 squared and the 6 to the power minus 1. They did not cancel those things. And then 2 squared is what? 2 squared is a 4. And then 6 to the power minus 1 is what?
1 over 6.
Yeah, it's like 1 over 6. You know? It's 1 over 6. But now, if you say 4 divided by 1 over 6, you can write like this. It's 4 divided by 1 over 6, which is the same as 4 times 6 over 1.
Get 24.
Get 24, okay. Okay. And Yewo ki answered. And that's the answer to the question. That's the answer. That's the answer to the question. So we continue. We continue. Next question. Yeah, you need to watch this video during your own leisure. I'm going to post it. Right, if x is an even integer and x is bigger than 1, arrange the following. What is this? If x is an even integer and x is bigger than 1, arrange the following in ascending order. What is ascending order? What kind of order is this?
Okay, kinano re etse as 2 to the power of x 0.
Yeah.
And then ebe re reng 2 to the power of x, and then ebe re re 2 to the power of x2. And
Okay.
then
Okay, Artome, let's start. Okay. Ringwala?
2 to the power of x 0.
To the power of x. Like this, to the power of 0, like this. Okay.
And then we ring 2 to the power of negative 2 to the 2 to the power of x.
Okay.
And then we ring 2 to the power of x2.
Okay.
And then we ring negative 2 to the power of x.
Yeah.
And then we ring 2 to the power of negative x.
Like this. Okay. Okay. Yeah, okay. It's like it's all, right? Okay, obviously now ascending order means from smallest to largest. That's what ascending order means. Okay, but if x is bigger than 1 here, The correct ascending order is the following. Okay, yeah, but thanks obviously for trying. It's the negative number. A number with a negative in front is the smallest one possible. So we're going to start with minus 2 to the power x. That is the smallest one possible because all these numbers are not negative, meaning they are positive. Okay, next. Then the next number is a number with a negative exponent. Because the negative exponent means 1 over 2 to the power x. Okay, if you have the 2 to the power minus x like this. Okay, yeah, you have this 2 to the power minus x. Then the next thing is now there's 0. Because x to the power 0 is going to be a 1 because x is bigger than 1. If x is bigger than 1, then x can be 2. What is 2 to the power 0?
Q1.
Q1, well done. Okay, so now this one is going to be like 2 to the power 1, which is 2. Yeah, so it's a positive number, so you can write this one. Then, so in other words, you're going to start with this one as the first one. Then we have the second one, the third. Okay, third, the fourth, the fifth, position 5. And this is the answer. And this is the answer. And this is the answer. Any question, Paul? This is the answer.
I gave.
Okay, good. Now we move to the next question. Okay, now question 2 is about solve for x in the junior exam, and this one came from the province. It's not just, it's from the provincial office. So yeah, you can expect this structure tomorrow. Solve for x. Let's solve for x. Like, let's look at this one. What do we do here to solve for x? If there is a big square root on one side, and this big square root is covering x, what do we do? What do we do? Okay, that's fine. If there's a big square root, you square both sides. Square both sides of the equation. So square both sides of the equation. Okay. So if you square both sides of the equation, you have the big square root. There's a big square root like this, and it is equal to something. The first thing is to remove this big square root. That's like a big umbrella. So to remove the big square root, what you do is square on the left, square on the right. And you get this. And you get this. Right, when you get this at this point, what do we do now? Okay, because now the square removes the square root. To remove the square root, we square both sides. Then the square root is gone. And then we have b squared. And then at this point, you want to solve for x. So we have ax equals b squared. We want to remove this a. And to remove that a, what then do we do? To remove this a, you divide both sides.
Got A.
Got a, well done. So we divide both sides, got a. So if you divide both sides with a, like so, we then are able to obtain, so this a cancels that a, leaving us with x, and we then have b squared over a, and this is the answer. And this is the what? This is the answer. So it is the answer to the question there. And obviously, I mean, it is true that this is the answer provided a is not 0. It is the answer provided a is not 0. So in mathematics, you need to prevent denominators from becoming 0. And we need to state up front that a is not 0 because we are dividing by 0. And a is unknown, is a variable. It is what you call a placeholder. Next thing, we'll look at 2.1.2. Any question first before we move forward? On this one here, any question that you'd like to ask? Something you'd like to understand? Why did we do this? Why? What else can be done, and so on.
Okay, understand.
We understand.
Yeah.
Good. Next point. Okay, so 2.1.2, which is 3 to the power x plus 3 to the power x minus 1 equals 36. What do we do here? Because we want to solve for x. That's the question. We need to solve for x. Mm-hmm.
3 to the power of x plus 3 to the power of x minus 1 equals to 6 to the power of 2.
Well, we can write like that. Brilliant stuff. Brilliant stuff. But first things first, but always do this. Always break this power that is x minus 1 or something. Like separate. So that we have 3 to the power x plus 3 to the power x times 3 to the power minus 1. This one you can read as something, but if you write it as 6 to the power 2, this one has no 6. So we can still write it like that. But we can write it 3 as 6 squared. It's also correct. But because there's no 6 on the left, it might not really be very, very helpful. Okay? It might not really be a game changer. Okay, what do we do next here? We look for the highest common factor because it's a plus. So yeah, what is the highest common factor? We need to factorize here.
The highest common factor is 3x. It's not 3x, it's 3.
Good. Yeah, I'll get 3 to the power x. Then we get what? It is 3 to the power x. Right, and therefore, if you pull it out, here there's only one of them, so we have a 1 plus. You cross this out. And then if you cross it out, then you have 3 to the power minus 1. See, if you take out the highest common factor, you always cross it out so that it doesn't confuse you. When you cross it out here, you're left with a 1 here because it was only 1. Here, you cross it out, and then you're left with 3 to the power minus 1 because you had only 3. We had 3 to the power minus 1 and the 3 to the power x equals 36. Next, what do we do?
Auto multiply, 3 to the power of x times 1.
Yeah. 3 to the power
And then
x. Yeah. Yeah.
And then it will 3 to the power of x times 3 to the power of -1.
Yes.
Yeah. Or 3 to the power of x times 1 is 3x. 3 to the power of x. And then 3 to the power of x times 3 to the power of 1 of -1 is 1.
Yeah.
And then it will equals to 36.
Okay, yeah, I get your point. So this is 3 to the power x. What we do now? We need to add. We collect items and add them up like this addition here. So it's 1 plus 3 to the power minus 1 is like 1/3, which is 36. So yeah, 1 plus 1/3 is what? 1 plus 1/3 is what? So yeah, it's like out of 1 here.
4/3.
Give 4/3. Well done. So yeah, we take out 3 as the LCD. We have 3 divided by 1. 3 divided by 1, which is 3 by times 1. 3 plus 3 divided by 3, it's 1. 1 times 1, it's exactly 1, equals 36. Okay. So we move in this direction. And then now we have 3 to the power x. What is 3 pi plus 1? Yeah.
Something.
Yes.
No, 3 plus 1/3. We cross
Yeah.
multiply.
Yes, if we're battling a cross multiplier, because the cross multiply is so that 3 times 1 becomes 3. 1 times 1 becomes 1. Then it'll divide like 1 times 3, about 3. 3. It's also correct.
Okay.
So that, yeah, so it's easy if you cross multiply these ones, because the fractions is 1 over 1 plus 1 out of 3. So you can cross multiply and say 3 times 1, get 3. 1 times 1 is 1. 1 times 3 is 3, right? And then now we have 3 to the power x, and we have 3 plus 1, which is 4 out of 3 equals 36. Then what do we do next? Okay, yeah.
Then, o ka se multiply 3 to the power of x times 4, and then lower 3 to the power of x times 3.
Yeah, definitely. It's all right. So yeah, we can do something here. We can do something here. Okay, now let's see what we can do. Oh, okay. Yeah, there's a couple of things we can do here, and this is very awesome stuff. It's awesome stuff. Right, so we need to take one odd number out. And if you take one odd number out, we get the following. You see, we have a disturbance here, and the disturbance is what? So we can remove this, because this one has no x. This has no what? No x, and the x is only the power of the number 3, meaning we can take the 4 out of 3, and this is equal to 36. We're going to do some magic here, and the magic is we want to solve for x, so we must remove this guy. We must deal with him. We must remove him. So to remove him, we multiply by the reciprocal of it. So we multiply by 4/3, and you also multiply by 4/3, like so. Okay, because you multiply by 4/3 and 4/3, what then happens? What do we achieve? Okay, 3 cancels 3, 4 cancels
4 cancel.
4. Good. So we multiply by the reciprocal. It's called the what? It's called the reciprocal. Right, it's called the reciprocal. So now we have this, which is 3 to the power x equals, okay, now we come to this guy. 3 equals how many times in 36? 12.
48.
Okay. Okay, you're getting 48. You already know. All right. So 36 divided by 3. It's a 12. Okay. 12 times 4. Give 48. You're so quick.
48.
Wow, you're so quick. It's super fast.
And then
Mm-hmm.
divide up both sides. Ka 3 hore 3
Yeah.
cancel na sale x.
Yeah.
And then how we use them?
Okay, just there's a small typo. Okay, there's a small typo here, because we must multiply by 3 over 4, so this must also be 3 over 4. This one is the red one, must be the same, because whatever we do on the left must be done on the right. Whatever we do on the left must be done on the what? On the right. So okay, because we multiply. Why did we multiply by the red thing? Why? Because we wanted to remove this 4 over 3. Correct. Wanted to remove this 4 over 3. So to remove this 4 over 3, you multiply it by 3 out of 4. So the 3 cancels and the 4 cancels. Okay, but now this is going to change this number. It's not a perfect square, it's 48, and that's why I'm getting worried. So we need to check everything. Now we come back. We simplify the right-hand side. So yeah, what answer do we get here, Ampo? We're so quick. So we'll say 36 divided by 4. What is 36 divided by 4? It's a 9.
Yeah,
Okay.
9 and then we'll times 3. 27.
Well done, 27. And 27 is a perfect cube. It's a perfect cube. And then we get 3 to the power x equals 3 to the power 3. Okay, 3 to the power x equals 3 to the power 3. Then what is this? (37) can write as 3 to the power 3, and then now we equate when the bases are the same, we equate the powers. Yes, we equate the powers. The base are the same. They're both 3 and 3, so it means x equals 3, and that's the answer. Any question? No question. You sort of understand this one. A little bit tricky, but yeah, but easy quite. Okay, this video, I'm going to send it to you, so you need to watch this video, okay? And play around with the video. All right.
Yeah.
Good. Next question. Next question is this one, 2.2.1. It has some greater than, it has solve for x in the inequality. That one, let's look at that one. Right, so the next thing we're going to do is this giant question that has some less than, greater than, and so on, and has some x element of z, has very scary things, and what is this? What kind of an animal is this? Okay, if you look at 2.2.1, x over 3 is bigger than x over 2 plus 1. What do we do here? What do we do here? What do we do here? Okay, obviously, I mean, to solve this one, we need to collect like terms. We collect like terms together. Right, that's what we do. So we're going to collect the x terms together. We like. And so with x over 3, and we have minus x over 2, and this is bigger than 1. We have collected like terms, and that's what we always do. Then here we take the LCD of these. Okay, 3 times 2, 6. 6 divided by 3. And if we want here, we can say we cross multiply here. We can like cross multiply. Yeah. So if we cross multiply here, it's going to be 2 times x. What is 2 times x? And 3 times minus x is minus 3x. And then 3 times 2 is a 6, bigger than 1. Okay. And then now here we have 2x minus x. What's the answer? 2x minus x is 2x minus 3x is a minus x out of 6 is bigger than 1. What do we do here, Paul?
Final answer.
Okay, but there's something we still can do. Remember, we need to solve for x. So, but would say x is less than, is greater than these, x is less than these. Yeah, then
divide by 6.
We'll divide by 6. Okay, yeah. We'll divide by 6. That's something that we can actually obviously opt for. Right. So that's something that it's very interesting. And we can always try that part. And as you are actually coming there and mentioning that one, and that's in Kosnati, right? Okay, right. That's the name I'm seeing on my screen here. Okay, so bigger than 1. So what we're going to do then here, we need to remove this 6. And to remove a 6 that is in the denominator, we multiply by 6, both sides. We multiply by 6. Multiplying by 6, 6 is a positive number, positive number. It means that it's just going to cancel this out, leaving us with minus x is bigger than 6 by 1, it's 6. But we're not yet done because it's still minus x is bigger than 6. So we need x alone. X must have nothing next to it. What do we do? What do we do? Because we're not yet done. There's still a minus x, and the examiner wants x alone, not minus x is greater than 6. They want x alone. So what do we do?
Divide by -1 both sides, and then negative go cancel a negative or select a positive.
Good. So we're gonna divide yeah, and obviously you can divide by that. Well done. So we can divide by -1. And we can divide by -1. And if we do that, this one is bigger than. So if you divide by negative, the inequality changes direction. Always. It changes what? Direction. Because we're dividing by a negative number. And then we have x here is less than -6. And this is the answer. It is the answer. Any question? Any question? Any suggestion in terms of what needs to be done? Any question and any suggestion in terms of what needs to be done? Where's a question here? Who has a question? No question. Think about the things we've done and we move to the next one. I'm going to ask you these things next time. So yeah, make sure you follow. Make sure you follow. Right. So if x is less than -6. Okay, if x is an element of z, x is an element of the set of integers, write down the first two numbers. Or rather the first two-digit number. Write down the first two-digit number that satisfies the inequality. Okay, good. So here we got x is smaller than -6. The examiner is saying if x is an integer, x is an element of the set of integers, write down the first two-digit number that satisfies the inequality. What do you think? What is the first two-digit number that satisfies this? What is it? 1 mark, just for you to pass. 1 mark. It's like go to matric. They want to push you to matric. They're giving you something easy so you can score 100 and go to matric and finish school. Okay, if x is an element of z, write down the first two-digit number that satisfies the inequality. Anyone? Nkosinathi Ompo. Right, yes. Right, so we continue. Right, so yeah, what do we do, guys? What's the answer then, Paul?
Hey, nah, I get it, yeah.
But like which is what's happening here? Because they're saying if x is an element of z, x is an element of the set of integers. In other words, x is an integer. Write down the first two-digit number that satisfies the inequality. What do you think is the answer?
Okasingoli X
Okay, so yeah.
into
Yes, okay, that's fine. So now, you know what you need to do here? You need to go back to the basics and say there's -6 on the number line, and there's -5, and there's -4, and there's -3, and okay, let me just write a nicer number line here for somebody to play around with this. Just look at this. So you can put -6 here, -5, -4, -3, -2, -1, 0, 1, 2, 3, and so on. And then you can put -7, and then you can put -8, and then you can put -9, and then you can put -10, and then you can put -11. So, but now you're saying x is less than these, but x is an element of what? Of the set of integers. So what do we do? So in other words, you're going to mark the integers like this. And this goes on. It goes on like that. Okay, the pattern goes on, but you are marking the dots. You are marking the integers. Okay, just like that. So obviously, if these are not integers, then you're going to sketch like this. Now we're asking the question. Write down the first two-digit number that satisfies the inequality. Which one satisfies the inequality here? Okay, so we need to pick one number here that is a two-digit number. Which one? Because now this is saying x less than -6. So numbers that satisfy the inequality are the ones where this arrow is pointing. -7 satisfies, but the problem with -7, it's not a two-digit number. So two-digit numbers are numbers of 2 digits, like 10, 11, 12, 15, 20. They are two-digit numbers, this. They're two-digit numbers, this. So what two-digit number, which one is the first two-digit number
10.
satisfies?
Negative 10.
Negative 10, and that's the answer. That's the answer. It's negative 10. It is the first one, because write down the first, because they can see, okay, if you go this way, because it's saying less than -6, so -7, -8, -9, just write down the first two-digit. The first one, because there are many like -11, -12, you can go on, and you can go on up to -infinity. But the examiner is saying, don't go far. Just pick the first that is having two digits, and it's -10. And that's the answer for 1 mark. Next question. Solve for x and y simultaneously. Okay, let's do the simultaneous here and yeah, have fun. Let's do the simultaneous here and have great fun. Let's do this simultaneous and have great fun. Okay, yeah. What's the answer to the simultaneous, guys? Anyone who's done? Is it long? Okay, what do we do with the simultaneous? I want you guys to dictate to me, because I want you to learn the simultaneous, because there are those small mistakes that you people make here. You make some sign errors, and you transpose things across the equal sign and next. So we need you to like show exactly what needs to be done here. Okay.
Okay,
Yeah.
so Chocoba,
Yes.
divide the two.
Yes.
The number. So
Yes, the y related to is not the number. Well done. Not the number. Yeah. So what do we do?
with y subject of the formula.
Well done. So we
Equation
identify
10.
the variable that has coefficient 1. Right, coefficient 1. So letter y is the subject of the formula. So what do we write?
Y equals to
Y equals
4 minus 2x.
Equals 4 minus 2x. Well done. So just transpose it. We just transpose the 2x, and then it became -2x, right? Next, what do we do?
Equation 1.
Equation 1. Okay, good. Yep.
And then Mona. It has to be negative. Positive y equals to 11 minus 3x.
11 minus 3x. Okay.
And then substitute key equation 2a.
Okay, key equation 2a. Okay.
And then substitute equation 1 into equation 2.
Then you can substitute equation 1 to equation 2. Okay, but watch out here. Because here you got 11 minus 3x. So 11 minus 3x. So you move this guy across the equal sign here. You see, if you move this guy across the equal sign, it then became -3x. Okay, it then became -3x. But which is correct. And then, okay, if you have this and you have 3x minus y equals 11, then you transpose this one, and then it becomes 11 minus 3x. What are you left with on this side? The y is negative.
We want like a negative.
Yes, definitely. Ring one like a negative ion, because it's coefficient, and it has the coefficient minus. It's okay like that, and we write it like that. Then what we do? Then we substitute
equation 1 into
equation 1 into
equation
2, and what we got?
Negative y equals to
negative y equals
11 minus 3 into 4 minus 2x.
4 minus 2x. Okay, I can see that substitute in the place of x. We have put 4 minus 2x instead of putting 4 minus 2x in the place of y, because it is y that is 4 minus 2x. So meaning wherever there is y, we need to put 4 minus 2x. So y is here in the next equation. So in the place of y, we must put 4 minus 2x.
2x.
And what we do, so there's y here, and y is 4 minus 2x, meaning in the place of y, you're going to put exactly, because y is 4 minus 2x, in the place of y appears here in the next equation, so you're going to put 4 minus 2x. And this 4 minus 2x, then it's 11 minus 3x, but there's a negative in front. You see the negative in front.
Mm.
You're able to see it, correct? Okay, you distribute here. If you distribute, what do you get? You get minus 4. You get minus 4 plus 2x equals 11 minus 3x. Then what do we do here?
And then what transpose?
What transpose? Yeah, we collect like terms. So we can have the 2x, then we bring 3x here. We have the 2x, we bring the 3x, it was minus 3x, now it's becoming plus. Then we have the 11, then the 4. The 4 is minus 4, bring it across, it becomes a plus. Like so. And what is 2x plus 3x?
5x.
11 plus 4 is what?
15.
What do we do here?
Divide up both sides by 5.
Divide both sides by 5. And what do we get if we divide both sides by 5?
3.
We get a 3. We get a 3. And that's the answer. We get a 3, and that's the what? And that's the answer. Okay, but now remember, this is the value of x, and y. We need to solve for y as well. But you need to remember that y is what? Y is the TA, right?
Yeah, so y equal to 4 minus
2x.
into,
yes. Okay, 4 minus
3.
2 into 3. Well done. So we substitute the 3 in the place of x. Then what you get here?
4 minus 6.
4 minus 6. Excellent. 4 minus 6. Then what do we achieve?
Negative 2.
Negative 2. And this is the answer. And this is the answer. So we're able to see, therefore, that this is the answer. So the answer is the answer is exactly negative 2. The answer is exactly negative 2. Next question. It's clear, right? You sort of understand what's happening here. Okay, good.
Yeah, why more negative y into equation number 1?
Okay, yeah, because go negative y, we can say equation 1, because equation 1 y equals 4 minus 2x, right? Yes, we can say equation 1 because equation 1a now y equals 4 minus 2x. So wherever there is y, we can put 4 minus 2x because y is equal to 4 minus 2x. So we can see y in the next equation. So now in the place of y, we put what? In the place of y, we then put 4 minus 2x. Yes, so we can see y here. And in the place of this y, what we put? 4 minus 2x. In the place of the y, we put 4 minus 2x. Okay.
Yeah.
You sort of understand. Okay, you're going to replay the video. Okay, you understand. Okay, good. We're going to replay this video and then you can watch again and make sure you understand. But there are the two answers. The two answers are x equals 3 and y equals minus 2. And those are the two answers there. Those are two answers. Next point. Study the patterns below and answer the questions that follow. Study the patterns below and answer the questions that will do what? That follow. What do we do? Okay, now we have this one. Pattern 1 has like 3 pieces. Number of sticks. Okay, patterns are the first 3 terms of a sequence for which the value of the term is given by the number of sticks in the pattern. So the value of the term Okay, so the value of the term is given by the number of sticks in the pattern. So here you have the value of the term. So what is the value of the term here? It's 3 because how many sticks are there? 1, 2, 3. So the number is 3. So here, how many sticks are there? 1, 2, 3, 4, 5. So there are 5 sticks here. How many sticks are here? 1, 2, 3, 4, 5, 6, 7. Well done. Good. So now they're saying write down the number of sticks in each of the first 5 terms of the sequence. First 5. Okay, let's start. The first one is 3, right? The next one is 5. After 5 it's 7. After 7 is what? Okay, so you can see that they're increasing by what, these things? Okay, because now it's 3, then it is 5. It increased. I got 2. Well done. And also this one is 2 plus 5. So you're able to see that you can write 5 plus 2. Right. So you can write a 5 plus 2 here, so that this one here is exactly 5. 5 plus 2. Right. So you start with 3, then you add 2 to 3, because if you say 3 plus 2, you get a 5. And you have 5, then you plus 2, you get a 7. So what is the next one, Paul? It's going to be 7
9.
plus 2, which is a 9. Next is going to be what? 10 plus 2, 11, and so on. Good. So this one is going to be exactly 9 and then 11. So obviously, these are 1, 2, 3, 4, 5. And write down the number of sticks in each of the first 5 terms of the sequence. And we've just done that exactly. Correct. So we're done. Because there are 1, 2, 3, 4, 5 of them. Okay. Right. So we're good. Next question is 3.2. Okay. What do we do in 3.2? What do we do in 3.2? Yep. What do we do in 3.2? Yeah. You see, 3.2 says write down the general term of the sequence. Okay, we've seen that it is 3, 5, 7, 9, 11. Okay. Then write down the general term, Tn, of this sequence. So yeah, let's write down the general term of the sequence. What is the general term of the sequence? Right, so if you have 3, 5, 7, 9, 11, what is the general term of this sequence? What is the general term of this sequence? Right, what is the general term of this sequence? Right, so the general term of this sequence is going to be, okay, now we need to find some differences here, and that is what we always do. So in other words, we start and say this one here is has the difference 2, and 5 minus 3 is 2. 7 minus 5, 2. 9 minus 7, 2. 11 minus 9, 2. Okay. So it means, therefore, this one is arithmetic. Do you know in arithmetic sequences? It is an arithmetic sequence. The formula for arithmetic sequences is Tn equals A plus N minus 1 times D. Do you remember this one, Paul? Maybe your teacher never told you this. Waihopula, okay? I'm happy that Waihopula, you remember it, okay? Right, so which means you have Tn. Okay, so the common difference is what you're getting when you subtract, and 2 is common, and it's the difference that's common. The first term is 3. So that we have the first term is 3, n minus 1 times the common difference 2. Okay, 3 plus 2n minus 2. And then we have 2n. What is 3 minus 2? Okay, so yeah, the answer is this. So write down the general term of the sequence, and the general term is therefore 2n plus 1. Any question? The general term is therefore 2n plus 1. Any question? Any question? No question. You sort of understand what's happening. Okay. Right. So let's move on to the next question. So you need to watch these videos, please, because I'm recording everything here. Everything that we're doing is like getting recorded. So you're going to watch it again when you are free. Okay. Tonight. I'm just going to send the video, the link, and then you can try the questions on your own, practice with the questions. And I'm going to send the questions on the WhatsApp group so that you can try as well. Next point. Okay. If you need to solve for T131. Okay, you already know that Tn equals 2n plus 1. Okay, Tn equals 2n plus 1. So they're saying find T131. So it means therefore that n here is 131. So it comes here and you have that n is 131. So that you have 131 equals 2 times 131. Okay, so you have that. So you have this one, which is 131 plus 1. What is 2 times 131? 2 times 1 is 2, 2 times 3 is 6, 2 by 1 is 2, plus 1. T131. Okay, what is 262 plus 1?
263.
Okay. Yeah, 263. Well done. 263. Okay. It's exactly 263. So here you're going to write 263. Next. 263. So obviously at this point you write T131, which is equal to 263. 26 what? 263. Okay, yeah, this is awesome stuff. So next point. Next point, we're gonna move to the next question. Okay, the next question is about the graphs, because obviously you're gonna see lots of graph questions, and this is the graph. This graph question is gonna be the last one. Right. So for this in this exam paper, not okay. So you need to learn the parabola. Right, so and the straight line. Right, parabola and the straight line. Okay, right. So you need to take note of this and make sure you understand these things. Let's look at the next point. Right, now the graphs f of x equals minus x squared plus 4 and g of x equals mx plus 2 are sketched. Okay, there are two graphs here. The parabola is f and the straight line is g. Okay, and they're sketched. Now a and e are the x-intercepts of f. Here are a and e are the x-intercepts of f. Okay, we're good. Next point. Right, now B and D are the y-intercepts of f and g respectively. Okay, we have B and D are the y-intercepts of f and g respectively. Now f and g intersected A and C. F and G, they intersected A and C. They count each other at A and C. Determine the coordinates of points B and D. Determine the coordinates of points B and D. So we need the coordinates of B and also the coordinates of D. What is B? B is nothing than, what do you call B? B is called the y-intercept. So B is the y-intercept of the graph F. So if you have actually the y-intercept of the graph F, how do you get the y-intercept? To get the y-intercept, you let x be equal to 0. So that now we have f of x, and f of x is minus x squared. Right, so f of x equals minus x squared minus x squared plus 4. But obviously this happens when x is 0, so that we have f of 0, which is minus 0 squared plus 4. Minus 0 squared is 0, giving us a 4. Okay, you need to determine the coordinates of the point B. So now B will therefore have the coordinates. B has the coordinates, the abscissor and the ordinate. So the x is 0 and the y is 4. Now this 0 is called the abscissor. And the 4 is called the ordinate. Okay, we're good. We're good. Right, so this is to do with the B, yes. Now to find the D is also the y-intercept, so you're finding the y-intercept. the y-intercept of G. Right, if you find the y-intercept of G, you let x be equal to 0. Okay, so yeah, let x be equal to 0 in G, and this is G of x equals mx plus 2, okay? Which means you're dealing with the G of 0, which is m of 0 plus 2. G of 0, m of 0 is 0 plus 2, which is 2. Okay, now giving us the coordinates of D. Okay, now you have here x is 0 and the y is 2. In the same way, the 0 is called the abscissa and y is called the ordinate. So determine the coordinates of B and D, and we've seen before the answers are B has the coordinates 0 and 4, and D has the coordinates 0 and 2. Where's the question? Any question? Where's the question? Any question?
Okay, so ha ile ko
Yeah?
like ile tsona ne?
Yes?
Mara ile ko line ya x-intercept we etsa exactly so.
Yes, if you're more in x-intercept, we are dealing with x-intercept. So if
Let
you
y
have
equals
that,
to
we
0.
let y be equal to 0, and yeah, it's everything like same. Okay, like similar. Okay, next point. Right, so here we need to write down the range of f. So we already know that the coordinates here, we've seen the coordinates are 0 and 4, and the coordinates of D are 0 and 2. Right, so write down the range of f. What is the range of f here? What is the range of f? Okay, f is this one. Yeah, what do you
The
think?
range of f ke yeah, ke sa le sure no.
Okay, that's fine. Okay, now the range is a set of y values for which this graph is defined. Okay, so now the set of outputs, all outputs of this function. So you can see it starts at 4 at the turning point. It's 4 at the turning point, and then it keeps going down here. It goes down, 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 down. Okay, right. So in other words, it will be y, but it is taking smaller values than 4. So y is less than 4. Because 4 is the biggest number, and then it takes like this 3 here, there's 2 here, there's 1. So it goes to 3, to 2, to 1, to 0, to -1, to -2. So it goes to the smaller values than 4, because -1, like 0 is smaller than 4. So you say y is smaller than 4 because it goes to the smaller values. It goes to 0, it goes to -1, it goes to -2, and somewhere here it goes to -10. So it goes to the smaller values. So y is less than 4. Y is less than 4. Okay. All right. Okay, yeah, we continue. Right, so yeah, we continue. Yeah, okay, next question. Determine the length of AE. Determine the length of AE if you know that the range is y less or equal to 4. B has 0, 4. D has the coordinate 0, 2. What is the length of AE? What is the length of AE?
Mo ntho ke e tsebang ne, a ke sure ka hata x mara ko
Yes.
y ke 0 because it's actually y axis.
Well done. So y is 0. So in other words, at this point, to find the length of AE, the A and E are x-intercepts. So we're going to deal with the x-intercepts because A and E are x what? Intercepts. So for the x-intercepts, you let y be equal to what? 0. You let y be equal to 0. Okay. So if y equals 0, what do we get? Right. So yeah, but you let y be equal to 0 in the graph of f. The parabola, in the graph of f, the parabola. So which means that f of x is equal to minus x squared plus 4, but you let y be equal to 0, which is minus x squared plus 4 equals 0. And then now you can write minus x squared equals -4, like this. Okay. And then now you can divide through by -1, getting x squared equals 4. X squared equals 4, so you take the square root on both sides. Okay, but you see, if you take the square root on both sides, there are a couple of things that are very important. So you put plus or minus here. Every time you take the square root, you put plus or minus, so that x becomes plus or minus 2. X becomes plus or minus 2. So it means that now you need to alter the things here. So here you have minus 2, and here you have 2, because it's positive on the right here, 0 is in the middle. The numbers, the values of x are positive on the line, on the real line here, and they're negative on the other side. So they'll, yeah, what is then the length of AE, Paul? What is then the length of AE? What is the distance from A to E? If it's minus 2 here and the other one, yeah? What is then the length of AE? It's 4 units. It is exactly how many units? 4 units. Because now you move from here to there, and it's minus 2 here, but distance is not negative. So distance is always what? Distance is always positive. So it's actually 2 units. So what you then have is that here you're going to have exactly 2 units. But also from here to here, it's going to be exactly how many units? 2 units. So 2 units plus 2 units is how many units? It's 4 units. Any question?
Okay, I can paper.
Okay, Peter, yes, because the Clarumela
Yeah.
video, I'm going to send this video, so you're going to have a chance to watch it. Okay, next point. Calculate the values of M. Here we know it's minus 2, 2, here it's 2, here is 4. Okay. And like so we're writing these as coordinates. Calculate the value of M.
More.
Yeah.
Ish o ka sebedisa formula midpoint because D as a midpoint.
Okay.
Mara o ka
Good.
sebedisa to calculate the coordinates of C.
The coordinates of C, right? Okay, good. Yeah, we can determine the coordinates of C. Yeah.
Sebedisa yang E.
Yeah. Okay, but remember that we have the equation, this one that has the M. So it is g of x is equal to mx plus 2. G of x equals mx plus 2. Right, so if g of x equals mx plus 2, now, all right, so g of x equals mx plus 2. Now, that is where the m appears. So you need to take a point that is on the graph. So the graph G passes through a point. Take one of the points, like it passes through A, whose coordinates you know, D, whose coordinates you know. Let's just pick A. With the coordinates minus 2 and 0, X and Y are part of this. So Y is 0, which is M. The X is minus 2 plus 2. 0 equals, what is M times minus 2? Minus 2M. You transpose this one, getting 2M equals 2. 2M, you divide by 2, both left and right, getting M equals what? M equals 2. M equals what? M equals 2. Okay, yeah. So, yeah, the question was calculate the value of M, and M equals 2. M is 1. My forgiveness. Okay, because divided by 2. 2 divided by 2 is 1. Okay, yeah. So, indeed, M is 1. M is 1. Right, so next we need to determine the coordinates of A and C, the points of intersection of F and G. Determine A and C, the points of intersection of F and G. Right, so let us determine this. Right, so the coordinates of A and C, the points of intersection of F and G. F of x, you already know, what is f of x? F of x is minus x squared plus 4. Minus x squared plus 4. And you already know that g of x is mx plus 2, but m is 1. so that g of x is just x plus 2 because m is 1. Okay, right. So we need to find the points of intersection. So to find the points, right, determine the points of intersection. How do you find the points of intersection? Right, so to find the points of intersection, you let. We're interested in the parts where these are equal. So in principle, you let f of x be equal to g of x. What is f of x? It's minus x squared plus 4. G of x is x plus 2. Transpose the x squared to the other side, getting x squared. And then it finds x on the other side. Okay, and then there's 2, and then the 4 becomes negative. So you moved everything to the other side. And then you're left with 0, but yeah, we write the 0 this side. Getting x squared plus x, 2 minus 4 is actually a minus 2 equals 0. Next, what do we do? X plus 2x minus 1. What's the answer? What do we do? Come, what do we do? X minus 2. X minus 2x 1. Okay. Yeah. Okay, so we're finding the coordinates of A and C. So we already know that A is minus 2, but it means therefore that here x is going to be 1, giving us the coordinates of A and C. So which means that A is going to have the coordinates x is minus 2 and y is 0, and C is going to have the coordinates x is 1 and y is 0. No. We need to find, okay, here, this one here, A has the coordinates minus 2 and 0. X is 1 here, but we need to find y. Okay, and to find y, you already know x is 1, but substitute into one of the equations. Well, in general, you substitute both to avoid mistakes. So you have x minus 2, x 1. Okay, that's an or. Use one of the equations like g of x. Okay, g of x is one of the functions, which is x plus 2. So when x is minus 2, you'd have g at minus 2, which is minus 2 plus 2. What is minus 2 plus 2? 0. And g of x equals x plus 2, which means g of 1 is 1 plus 2, and g of 1 is, what is 1 plus 2? It is exactly 3. Okay, so the coordinates of C are that x is 1, and we can see that y is 3. So when x is 1, y is 3. When x is minus 2, y is 0. This gives us the coordinates of A, and this one, the coordinates of C. So C will have the coordinates 1 and 3. C will have the coordinates 1 and 3. So determine the coordinates of A and C, the points of intersection of F and G. So A is the coordinates minus 2 and 0, and C is the coordinates 1 and 3. Okay, we're good. We're good. Okay, you're going to watch this video, please. I'm going to send a video, so you need to watch it and make sure you understand this. Okay, next point. Now, if k of x is equal to g of minus x, determine the values of x such that you have those functions there. So if k of x, we're doing 4.6 now, and the examiner said k of x is g of minus x, determine the values of x such that f is bigger than k. Right, so what do we do at this point? So you need to remember that the function g of x is the same as mx plus 2 it was given. So this is x plus 2 with m equals 1. Okay, now if it is g of minus x, it means therefore it's a kind of transformation, but it is a reflection. All right, so it is a reflection. Right. So now take note of the fact that what is happening here, x is becoming negative. So take a point, xy, and this point is transformed to this. Right, so x becomes negative, but that is the kind of transformation that is happening. X is becoming negative in G, and that is called K, the new function. So if G is like this, so we have that K of X is G of minus X, which is G of minus X, but G of X is X plus 2, so this one is going to be minus X plus 2. Just bring it down here. So this is going to be exactly minus X plus 2. Minus X plus 2. Minus X plus 2. Okay, yeah, minus X plus 2. Okay, good. Okay, look at this, which is minus X plus 2. So in the end, if it's minus X plus 2, it means that you are dealing with a reflection of the points of intersection. So you can use using the reflection of the points of intersection in question 4.5. Right, you'd remember that this is minus 2 and this is actually 1. Right. This is minus 2 and this is 1. So if you, all right, so if this is the case, remember, determine the values of x such that the function f of x is bigger than k. Right. So what then do we make of these here? Okay, there are a couple of things that you need to consider. So this is another function. And this function actually is a different function that is performed by this. Now, this here can be perceived as a reflection in the y-axis. Reflection in the y-axis. Okay, if you reflect in the y-axis, it means x becomes the negative. So, in other words, if you reflect 1, it's going to be minus 1. And if you reflect, so this, therefore, is going to be minus 1, but the y remains the same. So you're going to have minus 1, and the y remains the same. And we got the y to be 3 before. So you have a point here. And now you have this one, if you reflect here in the y-axis, so it's going to be exactly the same. So it's going to be 2. And you remember 2 was sitting here. And so it's going to be 2 and 0. So you're going to have something like this. Okay, right. So if you had to determine the values of x for which the f is above k, okay. Okay, so yeah, this is f in the and that. So okay, this new function is called k of x, but we are looking for where f is above k, right? So we're able to see that here is f, and here is k, the straight line. So f is above, it's here. It is above k. So where is it above? We can see therefore it is actually above between minus 1 and 2. Minus 1 and 2. And that's the answer. Between minus 1 and 2. So we're interested in the values of x for which this is the case, and therefore it is between minus 1 and 2. Right. So it was awesome discussing with you in my next, because you're writing paper 1, right, Paul?
Yeah,
right,
Monday
yeah.
to paper 2.
Yeah, good. Paper 2, then we're going to do it during the weekend. We shall spare time. Even tomorrow, we can spare time and do paper 2. Yeah, but thank you for joining us. It was awesome having you on board. Right, so I'm going to make the video available. Thanks a lot for joining us. See you again tomorrow or the weekend. I'll let you know. Yeah, thanks then. Goodbye. And have yourself a good night. I'm going to pause the video so that you can practice with this and replay. Okay. Right.
Bye-bye.
Yeah. Bye-bye, Emperor. Goodbye and have a good night.